Hi, welcome back to Moose in Chemistry. This is Chemical Equilibrium and Ice Problems, lesson number 3. Okay, we have got this first problem where it says KEQ for the reaction is 2HI, and a reversible reaction gives me H2 plus I2. The KEQ value is 1.40 times 10 to the negative 2. That's our KEQ value. If the concentration of the H2 and I2 are 2.0 times 10 to the negative 4, find the HI concentration. Okay. So what we're going to do is we're going to set up what we know. We know that KEQ is equal to 1.40 times 10 to the negative 2. Okay. We also know that H2 is equal to 2.00 times 10 to the negative 4. We also know that I2 also has the same value, which is 2.00 times 10 to the negative 4. Okay, so now we're going to go ahead and set up our KEQ equation. And let's see here. We've got, are you ready for this? It is the products of reactants. Here's our one reactant, A, and this is going to be called C and D. All right, so watch this. So it would be KEQ equals C times D divided by A square. Where's that square coming from? This 2 right there. All right, now let's go ahead and plug our values in. So our KEQ is 1.40 times 10 to the negative 2 equals our CD value, which is going to be, of course, 2.00 times 10 to the negative 4 times 2.00 times 10 to the negative 4. And what I'm going to do is I'm going to do something different here. Instead of call it HI squared, which I could, I'm going to call it X squared. All right. Now, what I want to do is I'm going to want to take the square root of this. So when I do, I take, this is the same thing as squared right here. See the 2.0 times 10 to the negative 4, 2 times 10 to the negative 4? That's the same thing as being squared. So I'm going to take the square root of this over the square root of all of this. And when I do, I get 0.1183 equals 2.00 times 10 to the negative 4 over x. So now I get 0.1183x equals 2.00 times 10 to the negative 4. And then all I have to do is bring the 0.1183 over and divide it into that number. And when I do that, that's going to give me 1.69 times 10 to the negative 3. So our HI concentration is going to equal 1.69 times 10 to the negative 3. Pretty darn snarly, I say. So our second problem here, and we have KC equals products of reactants because we're looking for the KC in this case. So, right, works like just like KEQ, you know. So here's our known concentrations. N2 is 4.0 times 10 to the negative 4. H2 is 2.9 times 10 to the negative 2. NH3 is 1.6 times 10 to the negative 2. Okay, we have our balanced equation right here. So what we're going to do is we're going to set this up. Okay, so now let's see here. We're going to have Kc equals products over reactants. So this is A, this is going to be C, this is going to be D. So it's going to be this, Kc equals, all right, products would be C bracket D cubed, because of this 3 right here, over A squared, because of this 2 right here. All right, all we have to do now is put in the values and do the mathematical magic. All right, so the concentration constant is going to be, let's see here. So it's going to be 4.0 times 10 to the negative 4 times our D, which is going to be our H2, 2.9 times 10 to the negative 2 cubed, divided by 1.6 times 10 to the negative 2 squared, right? So when we do our math, Kc equals 9.0, well, oops, 9.76 actually. So let me fix that there. It would be 9.76. I want to make that a little bit smaller too, give some room. Okay, there you go, 9.76 times 10 to the negative 7 divided by 2.56 times 10 to the negative 4. And my Kc value is going to be 3.81 times 10 to the negative 3rd. And that's it for this lesson. You guys be snarly, and we'll see you back here at Moosine Chemistry.